All right, calculus, welcome to, I think, your fourth video here for some trig prereq info that we need to have down. We're going to talk about the sum and difference trig identities. Again, have these notes down before the first day of school. From pre-calculus, did talk to Mr. Jones. He said you guys have these, you derived them. Sine of A plus B. A and B are angles, could be alpha, beta, theta, beta, whatever you guys use. Sine of A plus B is equal to sine A cosine B plus cosine A sine B. Cosine of A plus B is equal to cosine A cosine B minus sine A sine B. Again, you guys proved that, I believe. Now for tangent, honestly, tangent is just sine over cosine like we talked about on the previous, I think, video. So when I taught pre-calculus, I just showed this. It does have its own formula, but I think this is just fine when you have sine of alpha plus beta and cosine of alpha plus beta. I'm just going to call them that, A and B. Then tangent is just the ratio of sine over cosine. Those were the sum trig identities. Now the difference ones, sine of A minus B is sine A cosine B minus cosine A sine B. Cosine of A minus B is cosine A cosine B plus, so it's opposite there, sine A sine B. And then tangent of A minus B is sine of A minus B divided by cosine of A minus B. I would give my students a lot of these. So find exactly sine of 7 pi over 12. Let's pretend you didn't have a calculator. All right, so that is not a unit circle angle. No, it's not one of the special ones. First off, we're going to get this into degrees from radians. Okay, you're going to multiply by 180 over pi, you get 105 degrees. 7 pi 12ths radians is 105 degrees. Now, 105 is 60 plus 45. So another way of saying sine of 105 is saying sine of 60 plus 45. 60, 45. So I'm using this first formula up there. So it's going to be sine of 60 cosine 45 plus cosine of 60 sine of 45. And those all have lovely values. Sine of 60 is root 3 over 2. Cosine 45 is root 2 over 2 plus cosine of 60 is a half. Sine of 45 is root 2 over 2. You got root 6 plus root 2 over 4. Some calculators will spit that out to you, but it is important that you know how to do this without a calculator. Again, your college, and that's what I care about, your college might not allow them in the class. Find cosine of negative 15 degrees. Well, negative 15 is 45 minus 60. The order there, we 45 minus 60, it is a negative 15. Okay. So we have cosine of 45, cosine of 60 plus, it's always opposite there with cosine. You guys found that through the proof last year. Plus sine of 45 times sine of 60. And we get that. That's actually the same answer. Why is it the same answer? Because negative 15 plus 105 gives you 90. Gives you 90. We talked about something with 90 the other day. Remember, sine of 60 cosine 30. 60 and 30 add to 90. They were the same value. Interesting. All right, next page. Let's keep going. Here is where I would do a lot. So given cosine, okay, write this down. This is a great example. Given cosine of theta is negative 5 over 13 with theta in the second quadrant. Okay. And sine of beta is 3/5 with beta in the first quadrant. Find sine of theta plus beta, sine of theta minus beta, cosine of both theta plus beta and theta minus beta, And you guessed it, it's tangents of both the sum of theta and beta and the difference of theta and beta. All right, first thing we're going to do is we're going to look at theta. Theta is in the second quadrant. So here is my coordinate plane. Again, 0, 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, 360 degrees or 2 pi or 0. Okay, first quadrant, second quadrant, third quadrant, fourth quadrant. So I made a right triangle in the second quadrant that has a cosine adjacent of negative 5 over 13. This is negative. Why is it negative? You're going to the left. X is negative. Pythagorean theorem here gives you, this is a 5, 12, 13 triangle. Why is that positive? You're moving north. The radius is always positive. All right. So that's good. Then after beta's in the first quadrant. So I draw a right triangle in the first quadrant. Remember, the right angle is always made with the x-axis. Okay, so 3/5 is a 3, 4, 5 triangle. It's a positive 4 because you're going to the right. That is the positive x direction. So using that info, I know that sine of theta is 12 over 13. And I know that cosine of beta is 4/5 from the formulas we learned on the previous page. We know those are important. So sine of theta plus beta is sine of theta cosine of beta, sine of theta cosine beta, plus cosine theta sine of beta. Oh, we get the same denominators. These were always a blast. 33 over 65. 33 over 65. Sine of theta minus beta, folks, is going to be the same sine theta cos beta, cos theta sine beta as you had before, but instead of being plus, it will be a negative, be minus in between. So you already have 48 over 65. You already have the negative 15 over 65, but instead of adding them, you're going to subtract them. So you get 63 over 65. So notice sine of, the sum of the angles, sine was positive. Difference of the angles, sine was also positive. Interesting. Cosine of theta plus beta is that cosine theta, cosine beta minus sine theta, sine beta. All right, there is where I'm at. Cosine theta, cosine beta, sine theta, sine beta. You get a negative 56 over 65. So sine of theta plus beta was positive, and cosine of theta plus beta was negative. In what quadrant is sine positive and cosine negative? I think you guys know. We'll talk about that at the end. And then here, cosine of theta minus beta, instead of having a negative in the middle, like cosine of theta plus beta did, you're going to have a plus. So the same two fractions, but a plus in the middle. So notice how sine of theta minus beta was positive, and so is cosine of theta minus beta. In what quadrants is cosine and sine? Are they both positive? Lastly, tangent of theta plus beta is simply the ratio of sine theta plus beta over cosine of theta plus beta. Sine of theta plus beta, cosine of theta plus beta. Folks, take a look at this. 65, 65 are both denominators. They will cancel. You get negative 33 over 56. That'll happen for us a lot this year. Tangent of theta minus beta, well, we know that is sine of theta minus beta, divided by cosine of theta minus beta. Sine, cosine, look at that, 65 again. Cancel, cancel. So, because sine of theta plus beta was positive, and cosine of theta plus beta was negative, cosine x, sine y. Where's x negative and sine positive? That's quadrant 2. Theta minus beta is in quadrant 1 because both sine and cosine are positive. That was another question I asked when I taught pre-calculus. Okay? So we can gather that info from our answers there. All right, folks, I think that is a good place to end. Why don't we write these down here? Double angle trig identities. This is from pre-calculus. Sine of 2 theta, and really you can solve that You can prove that by saying it is sine of theta plus theta, and then do the sum of two angles identity to get that. Same thing with cosine of 2 theta. You can call it cosine of theta plus theta, and then solve it from there. Notice how it has 3. It has 3 because cosine squared minus sine squared, well, we can call sine squared 1 minus cosine squared, and we can call cosine squared 1 minus sine squared. That's how these other two, that's where they're coming from. And then again, tangent of 2 theta, you're just going to call it sine of 2 theta divided by cosine of 2 theta. And I think that is a good place to stop for this video. For now, Yak Math Videos, sign out.